Okay, so in this video today we're going to talk about reflections of functions. So how do we reflect functions? Now we are interested in two types of reflections. One is reflection about the x-axis, and the second is reflection about the y-axis. Excuse me. So let's look at reflection about the x-axis. Right? So let's consider our base function again. Let's take it to be x squared. So I have let fx equals x squared, and then let's take g of x equals negative x squared. All right. So what I'm going to do now is make our table again. So I have x. Okay. I have x squared, which is my fx, and then I have negative x squared, which is gx. So let's take the values negative 3, negative 2, negative 1, 0, 1, 2, and 3. So obviously x squared would be all positive values, that is 9, 4, 1, 0, 1, 4, and 9. And what the negative x squared does is it just makes all of the values here for fx to be negative. So I get negative 9, negative 4, negative 1, 0, 1, negative 1, negative 4, and negative 9. Right? So do we notice anything peculiar? We see that all of these are positive and all of these are negative. Obviously 0 is neutral. So what does that do to our graph? So let's take a look at our graph. So here are the points. So here's the table again. I recreated the table. And so here are my points for y equals x squared. And we see obviously that they fall on the graph of y equals x squared. Now, what do we notice about negative x squared? Well, we see that all the points have sort of flipped, right? It's kind of like it's their image across the x-axis. All right. So now when I click on the function negative x squared, what do we notice? We notice that this function is now reflected. It's reflected across the x-axis. Again, the size and the shape of the function haven't changed. What has changed is the orientation of the function. That is, it's no longer facing upward, it's opening downwards, right? So this function fx was opening upwards, whereas this function is now opening downward. So how do we detect reflections about the x-axis? So the graph of gx equals negative fx is a reflection of the graph of fx about the x-axis. Okay, so if you just make the function negative, then that function reflects over the x-axis. We already looked at what a reflection about the x-axis looks like, so I think you probably have a good idea of what reflection of our y-axis is going to do. So to test that, let's again pick a function. Let's pick fx equals square root of x. Now there's a reason I'm picking square root of x, and I will tell you that when we actually graph it. And then so that'll be our base function for now. And then we have gx, which is square root of negative x. Okay, so let's go ahead and make our table here. So I'm going to take x, and I'm going to take square root of x, and then I'm going to take square root of negative x. All right, and let's pick 4 points. I'm going to pick negative 4, negative 1, negative 1, 0, 1, and 4. So I picked these points deliberately so we don't get crazy decimals here. Now, what is the square root of negative 4? Well, I cannot take the square root of negative 4 because I cannot have a negative number, right? My domain for my square root function is all positive numbers, so this is undefined. Similarly, negative 1 under the square root is undefined. Square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. Remember, this is the principal root, so we're taking the positive square root, which is 2. Now, if you look at square root of negative x, if I put in negative 4, well, this is going to be negative square root of negative 4, right? which is square root of positive 4, which is 2. Same way, this one here is going to be square root of negative 1, which is square root of 1, which is 1. Well, 0 is neutral, so that's just 0. And now this here would become square root of negative 1, which obviously is undefined. And then we have square root of 4 will become, 4 would become square root of negative 4, which is also undefined. Okay. So let's see what this looks like on our graph. Okay. So here's the table. I've already put in the table here. And so obviously you see the 3 points here for square root of x. Also know that you're not going to see anything on the left side of the y-axis because those are all negative x's, and obviously they're not in the domain of square root of x. And so this is the graph we get for square root of x. Okay. So then let's go ahead and see what we get here. Well, the graph for square root of negative x here, the 3 points, we see that they are sort of a reflection about the y-axis, right? So when I go ahead and get my graph, I see that the graph and its image are symmetric about the y-axis. Okay, and this is one reason I didn't pick fx equals x squared. Since the function is symmetric, its reflection will also be literally just x squared.